Dear friends, let us discuss a few more problems related to this green theorem. What is the question here? Evaluate a line integral over c xy minus x square dx plus x square y into dy, where c is the enclosed curve formed by y is equal to 0, x is equal to 1 and y is equal to x by Green's theorem. Here the question is not to verify the Green's theorem, just to evaluate. That means we have to find out this value. That's it. Okay, now let us take the first function. So this is in the form of m dx plus n dy. Let us take m is equal to, what is that, xy minus x square, and n value is equal to second function, that is x square y. Let us find out the partial derivatives. So partial derivative of m with respect to y, keep in mind dou m divided by dou y. When with respect to y, keep x as constant. X into derivative of y is 1 minus x square is 0. Why? Because it is independent of y. That's why. Since it is a constant, derivative is 0. And dou n divided by dou x. So now y is constant of y into x square. If you differentiate, that is 2x. Simplify this. So dou m divided by dou y is equal to x only, and dou n divided by dou x is equal to 2xy. Now let us find out dou n by dou x like that using Green's theorem. Understand this. Here we are not verifying the Green's theorem, we are just going to find out those values using Green's theorem. Have a look on this. What Green's theorem says that a line integral over c m dx plus n dy is equal to a double integral over the region dou n divided by dou x minus dou m divided by dou y into dx dy. Instead of dx dy, I can write dy dx. Why? Because we are integrating first with respect to y, thereafter we are going to integrate with respect to x. So that's why. Now let us write the figure to get the points here. Okay, now let us write the figure here. So now understand the x-axis and y-axis one by one. This is x-axis, this is y-axis. Let us understand y is equal to 0. Y is equal to 0 is nothing but x-axis. Where y is equal to 0? On x-axis. Where x is equal to 0? On y-axis. Here the first condition is y is equal to 0. So x-axis, y is equal to 0. And x is equal to 1. Here x is equal to 0, x is equal to somewhat 1. X is equal to 1 is a line. This is x is equal to 1. Okay. X is equal to 1 is a line parallel to y-axis. Therefore, here the point of intersection is what? 0, 1, 1, 0. Because it is along which axis? X-axis. And here that is O of 0, 0. Another thing is that y is equal to x. As you know that y is equal to x is a straight line passing through the origin. So this is what? So this is y is equal to x. This is x is equal to 1. Therefore, intersection is some b is taken of 1, 1. Am I right here? 1, 1. Here the curve goes like this, goes like this, goes like this. This is what the region. Okay. Now understand here. Okay, what to do here? We have to take the point of intersection here. The first is with respect to x-axis. X is varies from 0 to 1, and y is varies from where to where? Y is varies from, this is y is equal to 0 to x. Am I right? 0 to x. Here the value of y is equal to 0. Here the value of y is equal to intersection x. Therefore, y is equal to 0 to x. Now write down dou n by dou x minus dou m by dou y. Dou n by dou x is what here? 2xy minus, dou m by dou y is x into dy into dx. First integrate with respect to y here. So that is equal to a line integral over x is equal to 0 to 1. So integrate that. So 2x into y with respect to y is y square by 2. We are integrating here. Minus x integrate xy. Because x is a constant, constant integration is constant into y from 0 to x dx. Now the remaining thing is x is equal to 0 to 1. So 2 to get cancel here, 2 to get cancel here. Just apply the upper limit enough, lower limit becomes 0. So when x is there, x square into x is x cube minus y is x here, x into x is x square into dx. Now if you integrate, what you will get? X power 4 divided by 4 minus x cube divided by 3 from 0 to 1. Just apply the upper limit, that's it. If you apply the upper limit, 1 by 4 minus 1 by 3. If you take the LCM, what you will get? 3 minus 4 minus 1 divided by 12. This is a line integral C m dx plus n dy. This is only they are asking here. The value of this integral over C m dx plus n dy, where m is xy minus x square plus n is what? X square y. The value is minus 1 by 2. 12. Got the point here. Okay, and now we can find out the last problem. Okay, evaluate over C y minus sin x into dx. This is a very beautiful problem, last problem of Green's theorem. So y minus sin x into dx. Understand the problem? Plus cos x into dy. Cos x into dy. Cos x into dy. Using Green's theorem. We just have to evaluate that value, that's it, not to verify the Green's theorem. So evaluate the integral y minus sin x into dx plus cos y into dy, cos x into dy using Green's theorem. So Green's theorem majorly helps us to find out the area in a plane, area between the two curves in a plane, that means xy plane. Here observe the problems. In all the problems in the Green's theorem, the variable z is absent, therefore it is defined only on xy plane, that means xy. Okay, now by using Green's theorem, write down the question by using the Green's theorem. Very beautiful question. Green's theorem. Where C is a triangle. Where C is the triangle. Joining the points. Very beautiful. Joining the points O of 0, 0 to A of 1, 0, A of 1, 0, and then 2, and then back 2, and then 2, and then 2, B of 1, 2, and then back 2, and then back 2. Since it is, why it is back? Since it is a closed interval, closed curve, and then back to O of 0, 0. Okay, first let us write down the consequences here. So this is, we have to evaluate this. So this is in the form of m dx plus n dy. Let us take m. So what is m here? Y minus sin x. Got my point? And n is what here? N is cos x. Now we have to find out the partial derivative dou m divided by dou y. So derivative of y with respect to y, 1, minus sin x is 0, because sin x, the variable x is there, with respect to y, that become a constant. So dou n divided by dou x, that is equal to minus sin x. Now simplify this. This is 1 minus 0 is nothing but 1 here itself. Now by using Green's theorem, as you know that Green's theorem, right? Write down the Green's theorem. Sir, what is the Green's theorem is? There are so many important factors are there. So line integral over C m dx plus n dy is equal to double integral over the region. So dou n divided by dou x minus dou m divided by dou y into dy into dx. Instead of dx dy, I can take dy into dx. Now let us find out the boundary conditions. That means from where to where they can rise. Okay, now let us understand the figure first. Okay, this is if you understand the figure, it is very easy to handle. Okay, this is x-axis, this is y-axis. Okay, where C is the triangle joining the point O of 0, 0. That means here. Okay, O of 0, 0, and then to A of 1, 0. X present, therefore x-axis A of 1, 0, and then what? And then B of 1, 2. Here 1, 2, B of 1, 2 I can take. B of 1, 2. Here how the triangle? So O to A, here O to A, and then to B, and then to B, and then to B, and then back to B to O. This is the region. Okay, and now let us understand this. Okay, along x-axis, I have to write something here. Along x-axis, to just for the understanding point of view. Along x-axis, what happens here? Along x-axis, x varies from where to where? 0 to 1. This is 1 point. Okay. Now we have to take along y-axis. Along y-axis, there are 2 points 1, 0. Along y-axis is nothing but AB. So line joining 1, 0 and what that 1, 2. So treat this one as x1 y1 and this one as x2 y2. Now let us find out the line equation. What is the line equation? We know that y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. That implies I can write here y minus y1 is 0. That means y divided by y2 minus y1. That means 2 minus 0. That is 2. That is equal to x minus x1. That means x minus x1 is what? X minus 1 divided by x2 minus x1. Something wrong here. 1, 0 to 1, 2. X minus 0 okay, we'll take something here. Okay, sorry, here we have to take along y-axis here 1, 0 to 1, 2, then back to here. This we can take it as 0, 0 to 1, 2. Then y by 2 is equal to x minus 0 divided by 1. Then cross multiply, therefore y is equal to 2x. And this is what? Equation. Y is equal to 2x. So y is equal to 0 to 2x. That itself here. And what about this thing is y varies from 0 to 2x. As you know that y varies from 0 to 2x. You can take the double integral now. So x varies from 0 to 1. Y varies from 0 to 2x. We can write this one dou n by dou x minus dou m by dou y. That is equal to minus sin x minus 1 into dx. dy into dx. If you take minus outside from the integral, so x is equal to 0 to 1 and y is equal to 0 to 2x, that you will get sin x plus 1 into dy dx. Now let us find out the value here. Okay. So with respect to y, okay, I will rub it. I will rub it now. Okay, what is that? So that is equal to x is equal to 0 to 1. If you integrate sin x with respect to y, sin x is a constant. Sin x into y. Okay, sin x into y plus integrate on of 1 with respect to y is y into, sorry, from where to where? 0 to 2x into dx. Okay, that is equal to x is equal to 0 to 1 sin x into 2x upper limit plus y is 2x, lower limit is 0, then it becomes dx. You can take 2 as outside, already minus is there, so minus 2, sorry about that, minus 2, x is equal to 0 to 1, sin x 2 outside, sin x into x is nothing but x sin x plus x into dx. Now understand this very beautifully. Here x into sin x is there. So product of the two function, when in an integration, when you have the product of two or more function, we have to apply the IP. What do you mean by IP? Integration by parts. What integration by parts says that first into integral of second minus integration of second ಏನು ಬಂದಿದೆ ಅದನ್ನು carry ಮಾಡಬೇಕು into derivative of first. Apply that. So here it is a first function, it is a second function. X into integration of sin x is minus cos x minus integral of what that, carry this one to here, minus cos x into derivative of x is 1 into dx plus x is what here, x square by 2. So from where to where? 0 to 1. We can apply limit later. Minus 2 times, look here, this become minus x cos x, minus into minus plus. If you integrate cos x, what you will get? Sin x plus x square by 2. From where to where? 0 to 1. Okay. Now minus 2 into, no need of applying lower limit here, just apply the upper limit. What happens here? Minus 1 into cos 1 plus sin 1 plus 1 square by 2 is 1 by 2. If you apply lower limit x here, all the quantity becomes 0. So now just multiplied by minus 2 here, minus into minus plus. What happens here? 2 cos 1 minus into plus minus 2 sin 1, okay, plus plus into minus, minus 2 into this is minus 2 to get cancelled, that you will get 1. So 2 cos x, so 2 cos x not x, that is 1. 2 cos 1 minus 2 sin 1 minus 1. This is a line integral c m dx plus n dy. This is the evaluation of the values. Got my point? So thank you so much. We'll discuss the Stokes theorem in the upcoming classes. Have a great day. Thank you.